So the purpose of this section is to take a non-standard structure, or certainly something that is more non-standard than what we've been working on up until now, and just see how our solver and our workflow handles it. Now, this is helpful for us because what it's going to allow us to do is identify areas where our solver could do with improving, or where our whole workflow could do with improving. So that's going to be the main objective here. Now, remember, the purpose of this course is not simply to have you watch me type out code and you to just kind of blindly copy it. I mean, you know that now at this stage. The real objective here is for you to get to the end of the course and obviously be able to use the solver to analyze your own structures. But more importantly, the real objective is that when you get to the end, that you have the confidence and the ability to be able to use what you've learned to further extend your solver. So, you know, the solver that you finish this course with should by no means be the end of the story for you. You should be able to go on now and improve this solver and make it suit your own needs. And part of what we're trying to do in this section is really identify what are the shortcomings and where could we do with improving this particular solver. So in the next lecture, we're going to take a closer look at the actual arch footbridge structure that we're going to be modeling. We're going to take a sort of a high level view of how we think the structure should work, and we're also going to have a think about some of the things that we need to consider, or, you know, how we're actually going to model it is really what we're going to be talking about in the next video. Then we'll actually set about modeling the structure. Now, if you've kind of only found Blender through this course or one of the other degree tutors courses, and so you're fairly new to Blender, you're going to find this lecture, I would say, quite helpful because I'm going to be demonstrating some of the really powerful modeling tools that Blender offers us. So I'll be doing things like using modifiers, in particular mirror modifiers, which help us do non-destructive modeling, and these are a real great way of speeding up your modeling workflow. I'll make use of reference images, and so if you're ever going to be modeling any kind of a structure based on plans, you're going to want to make use of those plans as reference images in Blender, and I'll show you how to do that as well. And then generally you'll see me use a lot of the really fantastic modeling tools, mesh modeling tools that Blender has. So if you've ever tried to build an actual large model in some of the big name commercial software packages, it can be painful. It can be really painful and slow to do. But Blender makes the actual building of our model an absolute breeze. And so you'll see that in that particular lecture. So when that's done, we'll transfer our data from Blender in the usual way. Nothing new here. We're going to take the data from Blender over into our notebook. In fact, I tell a lie, there is a slight new feature in there, in the sense that we've got different kinds of structural supports that we'll want to model, and so you'll see how we combine those different kinds of structural supports to bring them in and model them in our use them within our solver. And then finally, we're going to review our solver output. We'll run the thing and see what we see. Now, this is essentially the first step in what would ultimately be a really iterative process of analysis, digesting the results and making tweaks to your model and running your analysis again. We're going to do the first iteration of that in this section, but it's going to be quite instructive because it will flag up for us areas within our structure that, if we were to go on with this design, would need further, much more detailed analysis. And as I said at the start, it's also going to suggest improvements that we might consider making to improve the versatility of our solver. So let's just get stuck into it.